Okay, welcome all of you. Okay, in this session we are going to solve some problems based upon the how in the first session, in the first part I made the problem session into two parts. First part is for the calculation of size of the cable and size of the conductor. In the next part we are going to estimate the total internal wiring of the system. So before that, first let's have a problem. First problem is determine the size of the conductor for a two-core cable required to carry the maximum current of 60 amperes. There is a conductor. We need to find the size of that particular conductor, which should be carrying the 60 amperes of current, and it is given that length of the cable is 60 meters and declared supply voltage is 240 volts. What he has given? He has given current rating of that is 60 amps, and the length of the cable is 60 meter, and the voltage should be 240 volts. So he has given the supply voltage, length of the cable, and maximum current with which it should be withstand. So based upon that, we need to calculate the size of the conductor. So before first step is we need to find the permissible voltage range, permissible voltage drag. So while discussing about the discussing the size of the conductor, determination of the size of the conductor, there are three main factors that we need to consider. What are those? Minimum size, mainly for mechanical reasons, the current carrying capacity, and the voltage drop. So here the voltage drop is about 2%, is fixed for some particular ranges. That is the maximum voltage drop for supply terminals at any point on the installation. Maximum voltage drop from the supply terminals at any point on the installation not to exceed the prescribed limit of 2%. That is, it should not be cross the 2% of voltage drops of the supply plus 1 volt. That the permissible voltage drop for any particular point is, it should not be cross the 2% of voltage drops plus supply voltage and plus 1 volt. So here 2% of 240 plus 1 is 5.8 volts. This is the permissible voltage drop. Then how to calculate the ampere meters per volt of permissible drop? That we need to calculate here. This is, we can calculate based upon the total ampere meters in the circuit and divided by permissible voltage drop. Total ampere meters in circuit is it should be calculated by the length of the cable and the current that carrying the particular cable, the length of the cable and current carrying rating of that cable. Here he is given that 60 ampere of current is carrying for 60 meters of length cable. Here the length is 60 meter, but we have to calculate for both phase and neutral. For that purpose, we have to multiply by 2, because we are using single phase 2 wire system, and here one length of the one cable is 60 meters. For that purpose, we have to multiply by 2, because we need to take for both phase and neutral. That's why 60 into 2 is 120, 120 into 6 is 720. So the total 7200 total ampere meters in the circuit. Total ampere meters in the circuit is calculated by length of the cable into current carrying capacity of the cable multiplied by 2 divided by permissible voltage drop. Permissible voltage drop is calculated here. If we calculate this, we get 1.240. In the previous, see here, 1.240 here. After calculating the 1.240, the approximate ampere meters, see here, approximate ampere meters per voltage permissible drop is 1240. So by comparing this 1240 here, 1240 is, after calculating the approximate ampere meters per volt drop, we have to observe the table which I have explained in the previous session. We have to go for that particular table. Here 1240 is not given. For that purpose, what we need to do, yesterday I told that we need to check for next ratings. That is, next rating is 1475. So we have to consider this rating. So for that purpose, we have to consider the current cable of 19 bar 1.32 for the current rating of 74 ampere. See here, from the table, it is 74 amperes, 19 bar 1.32 meters, having current rating of 74 amperes, giving 1 volt drop for 1475 ampere meters. Since the current carrying capacity of the copper conductor cable size is 19 1.32, see here 19 1.32. This is the cable that I am going to consider. Selected 74 ampere, more than the circuit maximum current of 60 ampere, and voltage drop caused by the cable will be equal to, so total how much amount of voltage drop that its carrying is 4.88 volts, less than the permissible. So 7200 divided by 1475 divided by 1475, that is the next rating of 1240, use the 4.88. This is the less than the permissible voltage. So for that purpose, the cable which we have selected 19.1.32 gauge is permissible and it is needed. It's a good cable. The next thing is determine the size of the cable used for subcircuit, light subcircuit. There are two kinds of subcircuits. One is light, another one is a power subcircuit. Yesterday I told that the supply voltage may be taken as 240 volts. Only this much he has given. We have to calculate the size of the cable for light subcircuit carrying 240 volts. So first thing we should remember that in a subcircuit the maximum permissible load is 800 watts and maximum permissible points are 10. Like that, for maximum load of light subcircuit, if I am going to consider subcircuit of light subcircuit, that is it should be of 800 watts. If I am going to consider a subcircuit of power, then it should be 3000 watts. Like that we have to measure. Then assume the load as a pure light load. If you consider the load is a pure light load, then we have to calculate the current. We have the power ratings and voltage. We have to calculate the current carrying capacity of that particular subcircuit. Now how we can calculate? Just divide the power by voltage. We will get the current 3.33 amperes. So voltage drop and seeing the same within the permissible limits of 2% of declared supply voltage plus 1 volt is the most suitable cables. So in the while selecting of the cable, we have to calculate the permissible voltage drops. The permissible voltage drop should be always 2% of the supply voltage plus 1. So 2% of the supply voltage plus 1, that should be a permissible voltage drops. So the copper conductor cable size 1.12. This is the ampere current that I have got is 3.33 amperes. Here in current rating of 3.33 amperes is not given. For that purpose, what we need to, we have to go for next rating. Next rating is 5 ampere. Here for that 5 ampere current is the cable size should be 1 by 1.12. That is what they have purchased. They have selected. If the same thing is for aluminum cable, then 1 by 1.14. 1 by 1.14 cable. That's how we need to measure the size of the cable. That is, if the question is given to determine the size of the cable, first thing we have to calculate the permissible voltage drops, then ampere meters per voltage drops. That is when he has given the current rating directly. If he is not given the current rating directly, he may be given the which kind of subcircuit that is. So based upon that subcircuit and the supply voltage, we have to calculate the current rating. If once we got the current rating or once we got the ampere meter voltage drop, we can easily find the size of the cable. Okay, now let's consider the next problem. Next problem is, okay, determine the size of the cable required to carry the maximum current of 50 amperes. He has given the current rating of the cable, that is 50 amperes, and it is given that the length of the cable is 500 meters, and also he has given the length of the cable. So if he has given the current rating and length of the cable, so directly we can calculate the maximum current carrying capacity of that cable. And allowable voltage drop is 5%. If he has not given the allowable voltage drops, that we have to select the 2% for light loads, 5% for power loads of the declared supply voltage. And we have to calculate the size of the cables for supply voltage of 400 volt DC, 4 voltage volt AC. So here maximum load current carrying is I maximum is 50 ampere and the length of the cable is 500 meters. He has given the current rating and the length of the cable. then total ampere meters is, that is just multiply this 2 and by multiply these two, that is 500 meters and 50 ampere. He has directly given the length of the cable. That's why we need not to go for multiply by 2. If he is given only the cable length, that at that time we have to calculate multiply by 2. Okay. Oh. The next thing is we have to calculate the permissible voltage drops. Permissible voltage drops, for that he has given the 5% of allowable voltage drop. That's why we need not to go for 2% 2 divided by 100, just go for 5 divided by 100. 5 divided by 100 into 400. 400 is the supply voltage given. So that is 20 volts. 20 volts, just cancel these two, then 4 into 5 is 20 volts. So total ampere meters per permissible voltage drop is total ampere meters in the circuit. Total ampere meters in the circuit is just multiply length of the cable and current rating of that particular cable. That is 550 into 500 is to 25,000. So just take 25,000 divided by permissible voltage drop. Permissible voltage drop is 20. Then we get 1250. Now we have to go for that table. 1250. Where is 1250 here? 1250 is not here. So the next rating is 1475. 1475 is the length of the size of that particular cable is 19 by 1.32. 19 by 1.32, the cable that we have to select. That's how we need to calculate the size of the cable. Okay, now take the example of estimation. This is the actual, like these problems may comes also in your examinations. So draw the electric circuit and estimate the quantity of materials and total cost. We have to, a particular diagram is given. You have to draw the electrical circuit and estimate the quantity of material and total cost for PVC wiring system. PVC wiring system used in a hall of, he has given the total hall length, that is breadth, width and height, BWH, that is 15 meter, 6 meter and 4.5 meter height. 15 meter length, 6 meter breadth, 4.5 meter height. The hall is to be fitted with the fan points and light points. The hall should be contain fan points and light points. Make your own assumption for the number of fans, light points on the other missing data. That is, as given only we have to fit the fan and light points. It is not given the how many numbers we have to fit. We have to decide based upon our sub-circuit ratings. For that purpose, first we have to go for illumination, how much of illumination that it should contain, and total load that it should be, the particular connected load, that is floor area. Floor area is, that is area is calculated by breadth into length into breadth, that is 15 mm into 6 mm. It is about 90 m square. So for 90 m square, if I am going to consider the 10 watt bulb, 10 watt bulb for 90 meter square area, then it should be 900 watts of illumination that I required for particular that area. 900 watts. See here, this is 15 meter length, 6 meter breadth and 4.5 meter of height. For this area, I have to calculate the wiring. I have to illuminate and I have to place the fans also. So if I'm going for 10 watts of bulb, he has not given how many watts of bulb and how many watts of fan. That's why it's my assumption. So I'm going for 10 watts of bulb. I am placing 10 watts of bulb for 90 meter square of area. 90 meter square area for 10 watts is equals to 900 watts. Total connected load, total watts that required is 900 watts. So for 900 watts, I am going for 10 lamps with 100 watts each. 10 lamps with 100 amps each. And 4 ceiling fans of 600 watts. 4 ceiling fans and of 6 watts each. That is, I am estimated 10 lamps and 4 fans. I have to calculate the sub-circuits. First, I have to decide the sub-circuits. For that purpose, I have to calculate the loads. How many sub-circuits I need. That's why I have to calculate the how many lamps and how many fans that I require. So for that purpose, for 90 meter square of area, that I have calculated 900 watts of illumination. So for 900 watts, that's almost equal to 1000 watts. So for like 1000 watts, just take 10 lamps of 100 watts each. That's almost nearly equal to 1000 watts. And he has also given that you have to consider the fans also. So for that fan, 4 ceiling fans that I can place in the particular area. This is also based upon your requirement. If he is given in the example that how many fans and how many lamps that I need to place, so based upon that you can calculate. But in this problem he has not given how many numbers of fans and how many numbers of light. So based upon my sub-circuit ratings, that I am placing 4 ceiling fans of 600 watts each. So now calculate the total connected load. Total connected load is 10 into 1000 plus 4 into 60. That's equals to 1240 watts. And just I am assuming 240 volts. 240 volts, 1240 watts. Then the line current. For selection of size of the cable, I need to calculate the line current. So line current is calculated by connected load divided by total volts, supply volts, that is 5.2 amps. So for 5.2 amps, that I am going to consider this cable. This cable 1.18. Okay. Then since the maximum number of points in a circuit should be 10 and maximum load connected should be 800 watts. So we have to calculate the sub-circuits now. For calculating the sub-circuits, it should not be more than 10 points and it should not be more than 800 watts. So for that purpose, what I am doing here, I am making the two sub-circuits here, each having 7 points and 620 watts. Here already just see here 10 lamps and 4 ceilings. So I am dividing equally these two, 10 lamps and 4 ceiling. So totally 14 points are here. I am dividing just into 2. So 7 points each in sub-circuit. Each sub-circuit should be contain 7 points. See here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 lamps here, 5 lamps here and 4 ceiling fans. You can see here 5 lamps each and 2 fans. Here 5 lamps each and 2 fans. One fan number 2 and fan number 4 are in other sub-circuit. Fan number 1 and fan number 3 are in one sub-circuit. Lamp 1, lamp 2, lamp 3, lamp 4, lamp 5. These 5 lamps in one sub-circuit. 6, 7, 8, 9, 10. These lamps are in other sub-circuit. This is how I have decided the sub-circuit now. Okay. Now come for length of the PVC conduit. We need the conduit for carrying the cable. So that for that purpose we have to calculate the length of the total conduit. So based upon the circuit number 1, now consider this is the sub-circuit number 1. This is the sub-circuit number 1. For supplying the sub-circuit, we need distribution boards and electric meters, electric supply meters. The distribution boards get the supply from the service mains. Normally, the distribution boards are placed at the entrance of the house. This is, you can observe here. This is the distribution board. So while selecting the distribution board, that we have decided that the height should be of 1.5 meter and it should be away from the 0.2 meters. Distribution board and meter board should be of 0.2 meter and height of 1.5 meter. And this is the horizontal spacing and vertical spacing. Vertical spacing is here 2 meter from the ceiling. Always remember the distribution boards are placed to vertical spacing of 2 meters from the ceiling. From here, just take the horizontal wirings now. Horizontal conduit wiring. This is of a 2.2 meter. Horizontal is 2.2 meter. Vertical is 2 meter. This is how the distribution boards are placed now. This is from the meter board to main board. See here, from the meter board to distribution main board, that is of 0.2 meter spacing and vertical run of 2 meter. This is the vertical run of 2 meter. And horizontal run along the wall above the main entrance is 2.2 meter. That's what I already told, 2.2 meter. That is 2 meter from here and 0.2 meter from here, total 2.2 meter. Then horizontal run along the left hand wall of up to lamp 5. This is lamp 5. This is lamp 5. This is about total 15 meter. That I have to make my sub-circuit, make my connection from distribution board to the lamp 5. So how much amount of conduit or how much amount of wire that I need to require is this of total 15 meter, and each lamp while selecting the number of lamps and number of fans, I have told that the placing of lamps should be of 1.5 meter from the wall and 1.5 meter from the ceiling. Like that we have to place our lamps. In the while calculating the general rules, mainly what are the main general rules that we have to follow. In that I have told that 1.5 meter of gap should be given between the walls and cable, and 1.5 meter of from the height from the ceiling. That is given here. So totally 15 meter of length, and it is the total length is 15 meter. We have to minus this 1.5 meter because the length of the cable is from here to here. For that purpose, 15 minus 1.5, that is 13.5. 13.5 meter from the distribution board to the lamp 5. And the voltage drop along the left hand side of the switch SB1 and SB2. How much amount of voltage drops are there at SB1 and SB2? I have made the subcircuits, 2 subcircuits. One is at SB for controlling the left hand side SB1 and SB2, for controlling the right hand SB3 and SB4. For that purpose I have made 4 switch boxes, and each there will be a voltage drops at each subcircuits. That's about 2% of voltage drops. So in each switch boards, if 2% of voltage drops is 2 plus 2, 4 meters. And vertical run up to the ceiling and the run along the ceiling up to line L1, L2, L3, L4. Vertical runs. We have to calculate the vertical runs now. So L1, L2, L3, L4. These are the L1, L2, L3, L4. That's the hanging lamps. These are the vertical gap, means hanging lamps. So 1.5 meters should be given. Always remember 1.5 meters of length should be given. And these are about 5 meters. 5 lamps. That's why 5 into 1.5 and 1 meter of from the board. From this horizontal run 1 meter and 1.5 meter vertical drop. That's why 1 plus 1.5 into 5. 1 plus 1.5 into 5. That is 12.5 meter. This is about lamp 1, lamp 2, lamp 3, lamp 4. Then go for fan. Fan here. This is about lamp. Then about fan. Fan is of 3 meter plus 1 meter. 1 plus 3 meter into how many fans? 2 fans. Here 2 fans. And 1 plus 3. That is about 8 meter. This is about circuit 1. This is about circuit 1. Similarly, we have to calculate the PVC conduit required for subcircuit 2. Here subcircuit 2. Okay. Here total is 15 meter and minus 1.5 meter. Same here also. 15 meter and 1.5 meter. That is 13.5 meter. And vertical drop along the SB3 and SB4. See here, vertical drop along SB3 and SB4. This is the vertical drop. Here also same, 2 meters. Here 2 meters like that. Here also 2 meters. Plus 2 plus 2, 4 meters. Then similarly, we have to calculate the vertical drops for lamps and vertical drops for fans also. Vertical drops for lamp is 1.5 meter in vertical drop and 1 meter in horizontal drop. And fan also similarly here 3 meters in vertical drop and 1 meter in horizontal drop. It's given 5 into 1.5 plus 1, 2 into 1 plus 3, the 8 meter and 12.5 meter. After calculating the particular at sub voltage particular drops at circuit 1 and circuit 2, we have to calculate for total length of PVC conduit. 0.2 meters plus 2 meters. See here, 0.2 meters plus 2 meters plus 1.5 meters, 0.2 meters plus 2 meters, that is 2.2 meters plus 13.5 and 13.5 here. This is what given here. After calculating all the PVC conduit total length, that is we have to calculate from this distribution board to each lines. We can calculate the total PVC required, PVC conduit required, that is about 84.2 meters. By calculating all these things, from distribution board to meter board to each lamp and each fan and each subcircuit, the total PVC required is 83 meter, 84.2 meters. The wastage of about 15% is normally taken. That always remember 15% for conduits and 10% for cables is calculated as a wastage. So for that purpose, just calculate the 15% of how much 84.2, 15% of 84.4 is 12.63. Just add 84.2 with 12.6, that is 96.83 meters, always almost equals to 800 meters. So for 100 meters, we need 100 meters of PVC conduit. Okay, now come for the distribution board to switchboard SB1. How much amount of cable that we need to require now? That is till now we have calculated the conduit length. From now on we have to calculate the how much amount of length of cable that we need to require. That is from main distribution board to switchboard 1. Main distribution board to switchboard 1. How much required? 2 meters, 2.2 meters, 1.5 meters, 2 meters. See here. You people already know that switchboards should be placed at the 1.5 meters from the ceiling. 1.5 meters from the roof, floor, 1.5 meters from the floor. That he has given totally 4.5 meters. 4.5 meters of height. In that I have to place 1.5 meters. If I divide 4.5 with 1.5, then I get, see here, 3.5. In that 3.5, 2 meters of from the ceiling, 2 meters from the ceiling, 1.5 meter from the roof. Like that we have to calculate. So the length of the cable that required for SB1 is from the distribution board, 2 meters vertical, 2.2 meters horizontal, again 1.5 meter distance between the wall and the switchboards, and 1.2 meters downfall. See here, 2, 2.2, 1.5, 2, totally 7.7 meters. This is from till the SB1. I have to calculate from SB1 to remaining things. SB1 to lamp 1, fan 1, lamp 2, and see here, lamp 1, lamp 2, fan 1, lamp 3 also. Lamp 3 also. From the distribution board, the phase wire should be, will be go to the switchboards, and the neutral wires are always normally looped in lamps and fans itself. Lamps and fans. I will show the phase wires now. This is the phase wire for subcircuit 1. This is the phase wire for subcircuit 2. See here. This is phase 1, phase lamp subcircuit 2, subcircuit 1. Okay. I have got this phase wire till the switchboard 1. See here, this is the length, the cable which I am showing here. This is the phase wire. One wire go to SB1 and other wire go to lamp 1. From the lamp 1 and SB1. SB1 to lamp 1, SB1 to fan 1, SB1 to lamp 2, SB1 to lamp 3, SB1 to SB2. We need phase for SB2 also. For that purpose, we will get this phase from the SB1 here. I will explain one more time. Just observe carefully here. The phase should be get from the distribution board. See here. This is for subcircuit 1, subcircuit 2. From here, I got one phase here. From here, SB1, I have to give the phase to the each other points. So first one for our lamp 1, fan 1, lamp 2, lamp 3, phase 2, SB2. This is about phase. Then what about the neutral? And from the distribution board, a neutral wire goes to the lamp 1, and one more neutral goes to fan 1, and the other neutral go to lamp 2, the neutral go to lamp 3, the neutral go to fan 3, the neutral goes to lamp 4, the neutral goes to lamp 5, and the line, the neutral is ended here. From here the phase given to the SB2, and phase given from the SB2, the phase is given to lamp 4, phase is given to fan 3, and other thing is from this phase to SB1 phase is get connected. This is how we need to make the proper wiring. Now just calculate the length of the cable from SB1 to lamp 1 over SB1 to fan 2, fan 1, SB1 to fan 1, fan 1 is here, SB1 is here. So how much amount of cable required here? 3 meters, 1.1 meter here, 1.5 meters, again 2 meters. Here 2 meters, 1.5 meters, 1 meters and 3 meters, 7.5 meters. Like this I have to calculate for all the loads from SB1 to fan 1, SB1 to lamp 3, SB1 to SB2. See here, SB1 to SB2, SB1 to SB2. This is 2 meter, 1.5 meter, 1.5 meters, 3 meters, 1.5 meter, 1.5 meters, 2 meters. This 1.5 meter is the distance between lamp 4 and fan 3. And this 1.5 meter is the distance between fan 3 and lamp 3. This is the 3 meters because lamp the distance between these two. 1.5 meter here, 1.5 meter. We have to calculate total here. 2 plus 1, 3.5, 3.5 plus 1.5, 5, 5 plus 3, 8, 8 plus 3, 8 plus 3, 11, 11 plus 2, 13. See here, SB1 to SB2 is 30. Like this I have to calculate for all the things. Similarly in sub-circuit 2 also. Similarly in sub-circuit 2 also. Distribution board 2, switchboard 3. 2 meters, 3.5 meters, 5.5 meters, 5.5 plus 1.5. 7 plus 2, 9. See here, 7 plus 2, 9 meters, 9.3 meters. This is 3.8 meters. That's why 9.3 meters. Like that you have to calculate for all the things. After finding length of the cable from each sub-circuit board to different points, just add all the cables lengths. From here 7.7, 4.5, 7.5, all these things. You will get 145 meters. The 1.5 meters plus wastage of 15 or 20%. Then it's of 29 meters. That's totally 174 meters. This is about phase wire. Then I have to calculate for neutral. Neutral, no? From distribution to lamp 1. In the previous, in the every session I am discussing that phase should be connected to switches. Neutral should be looped in different points, whether maybe fans or lamps. From the distribution board you will get the neutral. This is 2.2 meters and 1.5 meters. This 2.2 plus 1.5 plus 1. 2.2 plus 1.5, 3.5, 4.5 and 4.5 plus 1.5. This is 6. This is 2 plus 2.2 plus 1.5 plus 1 plus 1.5, 8.2 meters. Similarly, lamp 1 to fan 1. Lamp 1 to fan 1. 1.5, 1, 1.5. 3 plus 4, 4 plus 1, 5, 5 plus 3, 8. See here, 8. Similarly, fan 1 to lamp 2. Similarly, I have to calculate from fan 1 to lamp 2, lamp 2 to lamp 3, lamp 3 to fan 3, fan 3 to lamp 4, lamp 4 to lamp 5. Then distribution board to lamp 5. I will show how to calculate for lamp 5 to distribution board. See here, 1.5 meter of vertical drop, 1 meter of horizontal drop, 3 meters, 1.5, 1, 2.5, 5.5, 5.5 plus 1.5. Instead of that, just you people already know this is the 15 meters. Here minus 1.5, 13.5 meters. So 5.5 plus 1, 2.5, 2.5 plus 13.5. 16 plus 2.2. 16 plus 2.2, 18.2. 18.2 plus 2, 19.20.2. This is how you need to calculate. Similarly for circuit 2. Similarly for circuit 2. Similarly for circuit 2 also you need to calculate. Then after calculating all the lengths, you will need to calculate total length required. Total length is 145. Here we got for phase. Okay, for phase 145 meter, for neutral 114 meter, then wastage with 125 meter, totally 174 plus 125, 174 of phase, 125 of neutral, total is 299, 300 meters. Say in this method used for determining the length and phase wire is very laborious one. As a general rule, the length of the phase wire may be taken approximately 2 times of that of neutral wire approximately. Normally what we need to do, we will first calculate the neutral length of the neutral wire and just multiply by 2. How much amount of length required is 125 meters, just multiply by 2. Like that we will calculate the phase wires. See here. So approximately the length of the phase wire and the neutral wires are taken here. Total length of the cable required may be taken as 3 times of the root. Before we have calculated the root conduit length, no? 100, we will just multiply by 3. If just multiply by 3, approximately that much amount of length of cable is required. See here, we got 100 here, 100, just multiply by 3. That much amount of cable is required here. This is how we have to calculate the length of the cable. Draw the electric circuit and estimate the quantity of material. We have estimated the quantity of how much amount of cable we need to require. And this is the costing. How the costing is takes place. Supply and fixing of 16 ampere 240 volt DPIC revariable type switch fuse unit on board, complete in all respects. The distribution board, what are the things that distribution board contain is fuse and DPST switches. So this is of quantity of 1. And supply and fixing of flush mounted two-way distributed board with MCBs. We need MCBs in distribution board. That's why we need one MCB. Supply and fixing of MCBs 5 amperes in number 2 above. Because we have 2 sub-circuits, for that purpose we need 4 MCBs. And wiring points of line points for light with 1.5 mm square insulated single core wire in PVC conduit pipe concealed in wall, complete in all respects. These are about 10 numbers we need to require. And above, but for fan points, 4 fan points are there, 10 lamp points are there. Like for that purpose we need. This is how the costing is takes place. Quantity and cost of each, then how much total amount required. Similarly, we can solve one more problem. See here, draw the electric circuit and estimate the quantity of material. He has given the electrical circuit already. Like these problems comes in your examination, he will give the one civil layout. He will just give one civil layout. We need to place the electrical quantities in that. Draw the electrical circuit and estimate the quantity of materials. You have to draw the wiring for this and have to calculate the how much amount of quantities of things we need to require. This is the given already. Height of the ceiling is 3.6 meters. He has given the height of the cable. Just assume 3.6 meters. Normally in our homes also it's about 3.6 meters. Height of ceiling. Okay. Now what he is given? He has given room, open to sky and hall. Open to sky. This is the entrance. So we have to place our distribution board at the entrance of our home. So I can place here or here. Wherever it is convenient. I have to place between this or here also. Here also. I can place here or here. Because this is the entrance. I can place here or here at the entrance of our home. Okay. Number of light points. 1, 2, 3, 4, 5. Light points. 1, 2, 3, 4, 5. Given. What is given? He has given the fan points and light points already. How many light points he has given? 1, 2, 3, 4, 5. And fan point is 1. Number of plug points. Number of plug points he has given as 2. 2 plug points we need to make. One at the room and another at the hall. Okay. So ISA recommendation, each wattage of each bulb fan plug socket are taken as 60 watts for the purpose of load estimation. The light and the fan wattage are taken as 60 watts each for the calculation each. Then just I am assuming that each is having the rated of 60 watts. So we have to calculate the total amount of load that is the wire should be carry. So totally how many number of points are there? 5 plus 1 6, 6 plus 2 8. 8 points multiplied by 60. 8 6 ja 48. 480 watts. So one sub-circuit is enough now. Here 480 watts. Each sub-circuit should contain 10 points and 800 watts. But here I have only 8 points and 480 watts. So one sub-circuit is enough now. Then total load 480 divided by supply voltage of 240, that is 2 ampere. For 2 ampere, 1 by 1.4 mm length of aluminum conduit is required now. 1 by 1.44 aluminum conduit for 650 voltage grade, which has a capacity of rated of up to 10 amperes. It's carry. Okay. Before going, just have how to draw the lines. How to draw the lines means, line means phase and neutral wires. Okay, as I already told, we can place distribution board here or here. In this here, placed here. From the distribution board, we have to place a switchboards, because the switchboards should be always placed at the common walls. See here, in just you people can observe in your home how the actual wiring is takes place. If you clearly observe the wirings at your home, then this estimation concept and estimation subject is very easy. Okay. See here, the switchboard is placed in between the walls for minimizing the length of the cable of wire. Okay. From the distribution board to main board to switchboard to fans and lamps. Fans and lamps. Similarly, here also from switchboard to lamps, different lamps it is placed. Okay. Let's just take the assumption that the height of the main board and switchboard are 1.5 meters. This is the basic general rule that we already studied is the height of the main board and switchboard should be placed at 1.5 meter from the from the floor, 2 meters from the floor. And height of the casing caping run at 3 meters. And height of the bracket light points are 2.4 meters. That we can assume. And from the distance between the meter board from the front wall in hall is 0.2 meters. About 0.2 meters that we need to remain the spacing. Okay, now go for length of casing and caping from the main board to meter board. Here the required 0.2 meters. So the cable required is casing caping required is also 0.2 meters. From meter board to switchboard 1. From meter board to switchboard 1 it is 2 meters. So plus 1.5 meters. See what is this 1.5 meters and 1.5 this meters. See, this is that 1.5 meters. This space 1.5 meters. This is that space 1.5 meters. 2 meter is horizontal drop and 1.5 meter vertical drop, 1.5 meter vertical drop. This 1.5, this 1.5 plus this 2. This is total 5 meters. And vertical run at the ceiling in hall. This is the hall, the ceiling run. This is 3.6 meters minus 3 meters. He has made the assumption, he has told that this is 3.6 meters. This is 3.6 meters. What height? Height of the roof. This is 3.6 meters. Let's just take it as 3 meters. Total is 6 meters. Run along the ceiling in hall. 2.5 meters, 2.5 meters, 2.5 meters. From switchboard to ceiling, fan and lamps. 2.5 meters, 2.5 meters, 2.5 meters. Drop from the ceiling to lamp 1. The lamp is there. The lamp is normally connected 1.5 meters below the, sorry, okay, here he has already given the height of the roof. Height of the roof is 3, and the cable is drawn up to 2.4 meters. So the difference gives you the drop of the ceiling. That's here 3.6 meters minus 2.4 meters. That is 1.2 meters. From switchboard 2 to lamp 4. This is the lamp 4 from switchboard 2. From here to here. Two vertical drops and one horizontal drop. 1.5, 1.5 plus 1.8. 1.5, 1.5 plus 1.8. It's a 4.2 meters. Okay. Then vertical run to ceiling in room. Here. Vertical run. That is 2.7, 1.8. Okay. Drop from ceiling to lamp 3. Ceiling to lamp 3. Here. This is 3.6 meters minus this 2.4 meters. Total length 5.2, 5.6, 7.2, 1.2. All by calculating all these things, we get 2.24.2 plus 15% of breakage. That is 27 meter, around about 28 meters. So this is how gives the length of casing cabling conduit. And we previously made an assumption that the total length of the wire should be always 3 times the multiplication of this conduit required. That's how the basic rule. Okay. Now let's calculate for phase wire. What I told in the previous problem, the phase should run from the main board to socket, so switch boards. From meter board to main board is 0.2 meter, and from main board to switchboard 1, that is from main board to switchboard is 2.1 meter. 2.1 meter plus 2.4 meters. This is 2.4 meters, 1.5 meters difference, 2 and 1.5 meters difference. 1.5 meter vertical drop, here 1.5 meter vertical drop and 2 meters of horizontal drop. So totally 5 meters we need to require. Okay, this is, I got phase from main board to switchboard. I need now swim free switchboard to fan. From switchboard to fan, one phase should be go. That is here 2.4 meters of vertical drop and 2 meters of horizontal drop. It is 4 meters total. Till 4 meters. Okay, then from switchboard 1 to lamp 1. From switchboard 1 to lamp 1. I will pass the phase wire through this conduit itself. 2.1 meters, 2.4 meters, 2.4 meters and drop of 1.2 meters. From SB1 to lamp 2. Same here, 2.4 meters, 2.1 meters, 2.4 meters, 1.2 meters. From SB1 to SB2. This is the wall. Normally the wall size are about 0.25 meters from SB1 to SB2. Okay. From SB2 to lamp 4, lamp 5, lamp 3. From SB2 that is 1.2, 1.5, 1.5 to 1.8, then 0.3, then 0.6. Total 4.2. Here from lamp 4 to SB1 to lamp 5 is 1.5, 1.8, 0.3, 0.6. Then width of wall 0.25 meter. From SB2 to lamp 3, 1.5 meter, 0.8 meters, 1.8 meters, 0.3 meters, 2.7 meters, 1.2 meters, in total 8.1 meter. So by adding these two, that is, see here 8.1, 8.1, 5, 4.5, 0.25, 4.5, 4.5, 8.1. We get 49.3, nearly about equals to wastage plus 8, 51.5 meters. Similarly, neutral. Neutral, how we need to go for neutral? Neutral are normally from main board to fans, fan to lamp, lamp to lamp, like that. Because it should not go to the common neutral will be connected at the switchboards. That's why the neutrals are normally linked here. This is the SB1 and SB2. From here, from fan 1 to neutral, fan 1 to lamp 1, lamp 1 to lamp 2, from lamp 2 to main board. like that. From main board to fan. From main board to fan. See here 1.2 to 2.4, 0.8. 1.5, 2.6, 2.4, 6.5. Like that, you have to calculate from each fan to lamp, lamp to fan, fan to lamp, lamp to switchboard. Same here. SP1, SP2 wall, from SP2 to lamp 4, lamp 4 to lamp 5, lamp 5 to lamp 3, total length 36.5, 6. And wastage of 3.6, total 39.25. 39.25 and 50 totally gives 90 meters. And here what I told, the casing caping required is 28 meters. Just take the multiply by 3. It's of about 30 meters. 30 into 3, 90 meters. See here 90 meters. This is how you can calculate. While solving the problems of internal wirings, what you people need to remember, first thing is we have to place the distribution boards and the switchboards at the entrance of our hall, at the entrance of our home. Okay, then we have to place the lamps, fans at the desired specified locations only. If he has not given any distance, how much distance we need to keep, that is in this problem he has given 3.6 meters. If he is not given in how much distance, that we need to follow strict rules, that is 1.5 meters of distance from the wall and falling off about 1 meters. Similarly here also we need to place the lamp and fan points at the desired locations, and we have to calculate the loads, total amount of load that each subcircuit should contain. So for that purpose we have to calculate the number of points. Each point should be, each subcircuit should be not cross 10 points and not cross 800 watts. And after calculating the total load with, and we need to calculate the how much amount of wire length of the cable, gauge of the wire we need to require. So for finding the gauge of the wire, we need to calculate the current rating. How to calculate the current rating? Just divide the total load divided by the supply voltage, we will get the current rating. See here, we get the current rating. If once we get the current rating, we will easily find the remaining things. This is enough for today. Remaining things we will discuss in the next session.